Hey Math 8. So I wanted to go over the answer for one IIS 2.1. The scenario was that you had 18 items in total between caps and shirts, and that the profit was $10 per cap that you sell and $5 per shirts that you sell. So the most important thing that we needed to define first was what the variables represented. So we did a let statements here saying that C is equal to the number of caps and S is equal to the number of shirts. So that means that the first equation, C plus S is equal to 18, is the total number of items, whereas 10C rather, would represent how much you make from caps. 5S would tell you how much you make from shirts. So adding those together will tell you your total profit. So we have two different equations from that scenario. Okay, so the basic idea is this is the actual same exact equation that we worked on yesterday in the video, and I had given you 3 steps just to review. Step 1 was solve one of the equations for a variable. Step 2 was substitute that variable into the other equation and solve for the remaining variable. And then step 3 was take that answer and substitute your answer into one of the original equations, and your final solution should end up with a coordinate point where the two lines intersect each other. So what 2.1 wanted you to do is they wanted to say, all right, well, you know how to do it graphically. Let's compare it to doing it algebraically now and see which method you like better. So what we did in the first part was took each of the equations and changed it into slope-intercept form by isolating one variable. Okay, the first equation for the total number of caps and shirt total number of items becomes y is equal to negative 1x plus 18. So the y-intercept was 18, and the line's going downwards. I'm just sketching it. Okay, C, which is our y, is going to be your number of caps, and this is number of shirts. So for example, this coordinate point right here, if you have 18 caps, you have 0 shirts to have a total of 18 items. This will be 1, 17, 2, 16, so on and so forth. Okay. Whereas the second equation, 10C plus 5S is equal to 125. If you use pouches and coins and do what you did the graded assignment on it to change standard form into slope-intercept form, you'll get something similar where the y-intercept is 12.5 and the slope is a negative 1/2. So if I were to sketch it, the y-intercept is at 12.5 and it's going to again be a negative slope but not as steep. Now, if you were to do this graphically, your point of intersection, this is your solution. But if you're sketching it without using Desmos, the idea is it's hard to know exactly where the point of intersection is. So instead, Jimfa did it in the 3 steps that we just talked about yesterday. Step 1, they isolated one of the variables or one of the equations for a variable. Actually, in this case, they did it for both C's. So they took this equation and changed it into slope-intercept form. Took this equation and changed it into slope-intercept form like we just showed you in the previous page. Okay. Now, the idea for step 2 is substitute that variable into another equation. So we took this equation and substituted all of this into the C. So negative S plus 18 is equal to negative 1/2 S plus 12.5. You're using pouches and coins. I collected the variables on the left-hand side, collected the coins on the right-hand side. Instead of dividing by negative 1/2, we multiply by negative 2/1, so the fractions cancel out as well as the signs, so we found out that S is equal to 11. Last step is to substitute this answer into one of the equations. So looking at the 2 original equations, I said, okay, this is an easier equation. So into the equation C plus S is equal to 18. That 11 that we just got, we plug it in to find out that C is equal to 7. In other words, now that I have 2 answers, 7, 11 is my solution. In other words, what that means is 7 caps and 11 shirts will give me I'm sorry, 18 items in total, and it will give me a profit of $125 in total. So this is your point of intersection. Okay. You're going to be doing a little bit more practice questions today. Have a good. Let me know if you want to come for office hours.